Okay, so we've seen how to add and subtract radicals. Had several examples of those. Again, remember, they're like clay variables. When you're adding and subtracting radicals, it's like clay variables. When it comes to multiplying, however, it's a little bit different. All right, so the big rule. Here's the rule, and I would make sure you have this down and you know it real well. The square root of something times the square root of something else is the square root of their product. And the best example I like to give with this is the square root of 9 times the square root of 4 is equal to the square root of 9 times 4. Well, I know the square root of 9 is 3, and I know that the square root of 4 is 2. And 9 times 4 is 36. Well, I know that 3 times 2 is 6, and the square root of 36 is 6. Right, so this is just an example to show that this property, right, that rule is true, and it works. All right, so remember, it's the square root of one thing times the square root of something else is equal to the square root of their products. Now, this is a fun rule that you could use both forwards and backwards, but for this video and for these exercises, we're only going to use this in the forward direction. So the square root of something times the square root of something else. All right, I'm going to multiply their insides. Okay, so let's take a look at our first example. Let's take a look at the square root of 3 times the square root of 7. There's nothing real fancy here. So the square root of 3 times the square root of 7 is the square root of 3 times 7, and everybody here knows that 3 times 7 is 21. So here I get the square root of 21. Nothing too terribly difficult with that. Now let's take a look at our second example here. Let's take a look at the square root of 6 times the square root of 12. Well, the square root of 6 times the square root of 12, that's the square root of 6 times 12. And 6 times 12 is 72. So now I have the square root of 72. Well, if I go here to some scratch work, I can take a look. The square root of 72, I already know breaks into 6 and 12. 6 breaks into 2 and 3. 12 breaks into 3 and 4. 4 breaks into 2 and 2. And my index here again is 2. So I know these 3's match up. These 2's match up, and this 2's all by himself. So that means I get a 3 out front, a 2 out front, and a square root of 2 stays underneath. 3 times 2 gives me 6, so I'm left with 6 square roots of 2. So the square root of 72 then becomes 6 square roots of 2. Now the question is, how do I know if I need to simplify, or how do I know if I don't need to simplify? So when do I simplify and when do I not simplify? Well, the general rule of thumb is always try to simplify. And if a number like 21, for example, you know that the factors of 21 are only 1 and 21, which nothing nice happens there, and 3 and 7. All right, there's no pairs that are going to come out. Now, if I look at a number like 72, I know 2 is even. So I know I can at least break it down by 2's. So I would try to break it down and break it down from there. I also use the idea that I already had 6 and 12 here to break it down on my next line over here. So sometimes it'll work out real nice. Sometimes it'll be very, very simple. All right, now let's take a look at a property that you're very familiar with called the distributive property. So using the distributive property. All right, so let's take a look. What happens if I take the square root of 5 and I multiply it by 3 plus the square root of 3? Well, I know the square root of 5, so I know I have to distribute to both the 3 and the square root of 3. So I take a look. The first multiplication I have is the square root of 5 times 3. Well, the whole number has to come out front, so I'll end up with 3 square roots of 5. My sign is going to stay the same. And then the square root of 5 times the square root of 3. I could write it out as the square root of 5 times the square root of 3. And I know that 5 times 3 is going to give me 15. So I'd end up with 3 roots of 5 plus the square root of 15. And you could exhaust all your options here, but the square root of 15 does not simplify. So this is as far as I'd be able to take it. Now I'm going to go over one more example. One more example here. What happens if I have something like 5 minus the square root of 2 times 3 plus the square root of 2? Well, now this is just the distributive property twice. So first off, I'm going to send 5 to both the 3 and the square root of 2. So 5 times 3 gives me 15. 5 times the square root of 2 is a positive 5 square roots of 2. And now I'm going to distribute the negative square root of 2. So negative square root of 2 times 3. Well, I have a negative, a whole number, and a radical. So I'm going to get negative 3 roots of 2. And now I have a negative square root of 2 times a positive square root of 2. I'm just going to write that out. Minus the square root of 2 times the square root of 2. And now I'm going to clean this up a little bit. Here I have a 15. Great. What's going on here? Well, I have a square root of 2 and a square root of 2. And as we saw with addition and subtraction, if I have 5 square roots of 2 minus 3 square roots of 2, I'd be left over with a positive 2 square roots of 2. And I'm going to take this minus sign, set them in. The square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 we all know to be 2. So I'm going to write this out one more time. Minus 2. The square root of 4 is 2. Well, I want to combine like terms. I have the whole number 15. 15 minus 2. These I can still combine. So 15 minus 2 is 13 plus, and then 2 roots of 2. So notice how we went from a binomial times a binomial, and after we simplify, we ended up with a binomial plus a binomial, or just a regular binomial, which I think is very interesting. This doesn't happen a whole lot. It happens in this with this type of work, though. All right, that should be enough to get you through the homework on 1.3. And again, as always, if you have any questions, make sure you ask with your homework.